This is a solution to WEX 250. So, factor the following quadratics or show they are prime. Okay, so that would mean, as a reminder, what prime would mean. That would mean that the corresponding equation uh, 2 times y squared plus 9y plus 9 equal to 0 would have no real solution. That's what prime would mean. But let's check. The easiest way to check would be the discriminant. So the discriminant would be b squared minus 4 times a times c. So that'd be what? 81 minus 72. 9 nines minus 8 nines. Yeah, so that'd be a 9. The fact that that's positive means that there are real solutions, and therefore it's not going to be prime. All right. So that means we should be able to do it. Okay, so then using the quadratic formula then to find the solutions. The solutions are y could be negative b minus the square root of the discriminant over 2 times 2. That's one possibility. The other possibility is that y could be negative b plus the square root of the discriminant over 2 times 2. Now, we computed the discriminant there. The discriminant is 9, and the square root of that is 3. So that would be y is negative 9 minus 3 over 4, or y is negative 9 plus 3 over 4. So that would be negative 12 over 4, so that would be negative 3. The other possibility is negative 6 over 4, so that would be negative 3 halves. Now, we know that solutions are in correspondence to factors. So therefore, we can say that the factorization must look like y minus one thing multiplied by y minus the other thing. And what we need to put in there are the solutions we found. So negative 3 can go in that one, and negative 3 halves can go in the other one. And then to get it right, we have to take this coefficient and put it right there, that 2. So to make it look just marginally nicer, it would look like 2 multiplied by y plus 3 multiplied by y plus 3 halves. Okay. So how about the next one? Let's compute its discriminant. The discriminant would be negative 1, that's b, squared minus 4 times 2 times negative 8. Okay, well that's 64 and one more, so that's 65, which is positive. as a result, this quadratic does factor. It's not prime. So then I'll use the quadratic formula. That tells us that w could be negative 1. Subtract the square root of the discriminant, which we found to be 65, over 2 times 2. Or w could be negative 1 plus the square root of 65 over 2 times 2. So w could be 1 minus the square root of 65 over 4. That's one possibility. And the other possibility is that w could be 1 plus the square root of 65 over 4. So those are the two solutions, and again, solutions are in correspondence to factors. Therefore, we know that the factorization needs to look like w minus one of the factors multiplied by w minus the other factor. So again, these solutions just get routed into place. So this one I'll do 1 minus 65 over 4 in that one, and then this one is 1 minus the square root of 65 over 4. And then finally, to make it right, if we were to multiply this out right now, the result would be monic, but what we're factoring is not monic, so this leading coefficient needs to be put in. So there it is.